Mr. Blue Pen here.
Mr. Pencil.
And we're going to do a little bit of 9-point circle discussion. Now, the 9-point circle goes through the feet of the altitudes, the midpoints, and the points that are 1/3 or 2/3, depending which way you're pointing, between the orthocenter and vertices. So those last 3 points don't get much press because it takes so long to say them. So we're going to focus on midpoints and feet of altitudes. Now, there is one very special case of 9-point circle, and that's when you have the most symmetric triangle possible. Now, I think you can see these pencil marks here. I actually constructed an equilateral triangle using this side down here as the start. You can see this arc coming up here and this arc coming up here to guarantee that these two sides are also the same size as this side. So I've got an equilateral triangle. I did the construction for angle bisectors. So this guy here and this guy here, angle bisectors, and then I just laid down my ruler to connect this intersection with those. So this also is an angle bisector, but in equilateral triangles, the angle bisectors are also medians. So that's a midpoint, that's a midpoint, that's a midpoint. Oh, and in an equilateral triangle, the angle bisectors are also altitudes. So Mr. Pencil, what other thing besides a midpoint is this point?
That's the foot of the altitude.
Oh, well said, Mr. Pencil. Very good. Just a second. This guy. Let's get him in the picture there. All right, that one. Oh, he's kind of shadowy. What can we do to get him to look better?
Other side?
Have him come from that. That looks a little better. Yeah,
sure.
All right, good.
Sure.
And this is Stupid Rat Creature. He's with us from Bone Comics. I don't know if you read Bone. All right, now, we're going to construct a 9-point circle on this larger triangle. Let's zoom in. Now we can see, and you're not supposed to judge by appearances too much, we can see that this angle is almost 90, but not quite. We can see that this is definitely not an isosceles triangle. So we're going to get a 9-point circle that doesn't have the worries of the special kinds of triangles. So I'm expecting a circle that cuts through each side twice. One for a midpoint, one for a foot of an altitude. But to construct a 9-point circle, you don't construct all 9 points. Did you know that, Mr. Pencil?
It seemed excessive because you only need 3 points for a circle.
Oh, well said. That's very good. I love the way Mr. Pencil talks. So I'm doing a midpoint over here, the usual midpoint construction. So now I'm going to lay down my crappy ruler. Whoops. I'm using my Burger King ruler here. And maybe Mr. Pencil can draw that. All we want is the midpoint. There we go. Okay, good. Midpoint especially marked. We're going to do that again for each side. We need all 3 midpoints. That's the way it is. So I'm going to get the midpoint here. Mr. Pencil, get ready to draw.
Yes. Looks like you need a little more.
It wasn't long enough. So now we have. He's gonna. Mr. Pencil also has Mr. Eraser attached by a metal collar, kind of kinky.
All right.
All right. Let's see. So this is definitely more than halfway. All right. So we've got this arc here, and I made a really big arc because I'm just feeling so vulnerable now. All right, so that one, just to emphasize the midpoint, we don't need too much more than that.
Yep.
All right, so let me talk while Mr. Pencil's working. We actually want 3 midpoints because the foot of the, sorry, not the foot of the altitudes, the 9-point circle goes through all 3 midpoints. So what we're actually doing is finding 3 midpoints and then making the circumcircle of the midpoints. Making the circle that goes through all 3 midpoints. Give me that vertex there. A little bit more space. Gotta make sure I'm more than halfway. And all right, one more midpoint. So we get the 3 midpoints. Now in Sketchpad, this is really easy because you would select a side, and it gets that little halo around it, and then go up to construct, and it will say construct midpoint, and the midpoint appears. You don't have to do this stuff. But on paper, here's what it looks like. Now, let's draw in with our Mr. Pen the triangle made of midpoints whose circumcircle we're going to do. So Mr. Pencil, do you know how to do the circumcircle of a triangle?
Am I supposed to say no for the video?
That's fine. You can say yes or no, whatever you want to do.
Let's say no for instructional.
Okay, so I don't know how to do the circumcircle Well, you can look it up in your book. Isn't that great? And the circumcircle is you do the perpendicular bisectors of two sides. They meet at the circumcenter. So what's weird about the 9-point circle construction is it is literally five perpendicular bisector constructions. You do a perpendicular bisector, perpendicular bisector, perpendicular bisector, perpendicular bisector, perpendicular bisector. You finally find the center of the 9-point circle. So we're going to do 2 more perpendicular bisector constructions, which is one that is tedious on paper here, because look at all these arcs I have to draw over and over again. But on Sketchpad, you just keep constructing those midpoints and perpendicular bisectors at the very end. I think it's this guy.
That one, yeah.
Yep. All right, lay it down. Mr. Pencil, do pen with this one. We want to really emphasize this. Because this time, we don't want just the midpoint. We want the full perpendicular bisector. So that's another thing that comes from experience working with the materials. Sometimes you really only care about the midpoint. Sometimes you care about the perpendicular bisector. Draw it.
Fully?
That's
Or... you just want it.
That's pretty good, but I would mark on each of these X's to show where this segment came from.
Sure.
That's the so if it's
I'll just extend it.
Yeah, if it's to hand in for a grade, you want somebody else to be able to read your construction. So the professor reading the construction would look and say, okay, I see a midpoint from, I can see these arcs perpendicular bisector. A midpoint, I can see these arcs perpendicular bisector. Here's a midpoint, and the crossed arcs are really close by, so I know you did perpendicular bisector. Here's a perpendicular bisector fully drawn in, because we don't know where it's going to intersect the other perpendicular bisector, and the other perpendicular bisector is going to be for this longer segment up here. I don't know if there's even a special name for a segment joining midpoints of a triangle, but we do know this. A segment joining midpoints is parallel to the side opposite. So these two guys are parallel segments if we ever need that property. But we certainly aren't using it this time. All right, one more time. Here we go. I hope this is enough. All right, I catch it. I catch just that toe there. Can you see it, Mr. Pencil?
I see it.
All right, so draw in the full perpendicular bisector, and then Mr. Pencil is going to become Mr. Compass and draw the 9-point circle. Hello, Dr. Spencer. You want to be in our video?
It's tempting, but I have to go too.
All right, so that's the center. That point right there, there's the center. And then Mr. Blue Pen becomes Mr. Compass, takes the hand off. He's going to have to adjust the radius. And here we go.
That could be Mr. Marker.
Is that the spot?
That's out of ink.
Right.
Now test to see if it catches all 3 midpoints. So there's one midpoint. Oh, that's a catch. That's really close. And that third one you're on, you could tighten it just a hair. Just reduce the radius by a hair, and I think it'll be money. So we're going to catch that midpoint. You can draw that circle.
Just double checking.
Yeah,
Right.
Triple checking is good. So now drawing the 9-point circle, Mr. Compass is doing this stuff, and the stupid rat creature is watching. I see a 9-point circle.
There it is.
Yep. Now let's observe. Oh, this is kind of nifty. There's an intersection here that doesn't mean anything, but it's quite a coincidence. This would be the foot of the altitude from that vertex, because the 9-point circle goes through those. Mr. Blue Pen, or whoever he is now, let's see if that looks like a right angle. And it does. I mean, if we just look at my ruler forms a right angle with this side, because that's the foot of an altitude, an undrawn altitude. But the 9-point circle catches those. So this guy, since that's the midpoint, that must be the foot of the altitude from that vertex, this point here. And we could draw it in if we wanted to, but that's the right look. And this intersection of the circle with this side, ignoring this other extra arc from a perpendicular bisector construction, that would be the foot of this altitude. And it looks like money. It's right there. It's really good. So the feet of the altitudes look good. That's the 9-point circle for this triangle. But now let's pull back a little bit and compare. The fully symmetric version, so clean, so simple. It kind of looks like Harry Potter with the Deathly Hallows. You got the circle, you got the triangle, you got the wand. This one doesn't look like Harry Potter and the Deathly Hallows. It's much more complicated. But I'm hoping that the people can see on the video the penciled 9-point circle. Now I would advise everybody to be able to spot the structure of a 9-point circle, because any combination of points that are supposed to be on the 9-point circle would be on the 9-point circle. So for instance, there's a question on the wiki that says, is the quadrilateral through this midpoint, through this midpoint, through this foot of an altitude, and through this foot of an altitude, is this quadrilateral cyclic? And the answer, Mr. Pencil, would be
Yes.
yeah.
Because they
Why?
fall on the 9-point
They're on the 9-point circle.
Cyclic quadrilateral.
Proof done.
All of its vertices.
You
lie
guys
on a
got to
circle.
watch for that kind of stuff because your professor loves those kind of questions. And there's questions like that that stay blank all week because people are intimidated by the word prove. All right, we're going to end this video. We hope you really like it. And subscribe and send us money.